Santha Academy. Welcome to Digital Kaksha. To get updates on new videos, click the subscribe button and the bell icon.
Hello everyone, good morning. This is your teacher presenting here a new topic of chapter Metals and Nonmetals. The topic is chemical properties of metal oxides. So, we have understood in the previous video that how the metal oxides are being formed. When metal reacts with oxygen, then metal oxide is formed. Also, we have discussed about metal oxides' nature, that metal oxides are basic in nature. To test them, we can use indicators. In litmus solution, if we are putting a metal oxide, since it is basic, it is going to convert red litmus to blue. Now, since metal oxides are basic in nature, and if they are going to dissolve in water, they will be called as alkali. So, first reaction is reaction with water. Now, since I have told previously that all the bases are not alkali, that means all the bases cannot dissolve in water. So, there are very few metal oxides which dissolve in water. If a metal oxide is dissolved in water, it forms metal hydroxide. Like if sodium oxide we are taking and dissolving it in water, it forms sodium hydroxide NaOH. Similarly, potassium oxide, that is K2O, combines with water H2O to forms potassium hydroxide KOH. So by this we can say that metal oxides when treated with water forms metal hydroxide. But again I am saying metal oxides are not completely dissolvable in water. Means all metal oxides are not soluble in water. Some metal oxides are there which do not dissolve in water and they are not alkali, but they are dissolving in acid or base. So the next reaction is reaction with acid or base. Now I have taken zinc oxide is reacting with NaOH base to forms Na2ZnO2. It's a salt sodium zincate plus water. Now recall the reaction. Acid plus base gives salt and water. So we are getting salt and water and this is base. So by this it is clear that zinc oxide is acting as an acid over here. Now next reaction, ZnO, again zinc oxide reacting with HCl, it's an acid. So we are reacting zinc oxide with an acid. It's forming ZnCl2, that is salt and water H2O. So again it is forming salt and water by reacting with acid. So it is acting as a base over here because in neutralization acid and base combines to form salt and water. So with base it is behaving as acid, with acid it is behaving as base. So we can say that zinc oxide is showing both the behavior acidic as well as basic. So if metal oxides shows both behavior acidic and basic, then they are called as amphoteric oxides. They are called as amphoteric. So they are called as amphoteric oxides. Similarly, when we talk about aluminium oxide reacting with NaOH, it's a base, and forming aluminium sodium aluminate. It's forming sodium aluminate plus water. So salt and water is being formed when aluminium oxide reacts with base. So here it is acting as an acid. In the next reaction, I am reacting aluminium oxide with acid. It's forming aluminium chloride and water, salt and water. So here with acid it's forming salt and water. That means it is acting as a base. So again we can say that aluminum oxide, since it is showing both the behavior acid as well as base, it is also called as amphoteric oxide. So we understood the properties of metal oxides, that they are basic in nature. Some metal oxides dissolve in water to form metal hydroxide, and the basic oxides, some are not soluble in water. So they are soluble in acid or a base to form salt in water. So they shows their basic and acidic behavior. After reaction of metal oxides with water, acid and base, we are going to study reactivity series of metals. Now, we know that so many metals are present in our earth crust, but among them some are highly reactive, some are very least reactive. Like when we talk about potassium, sodium, we have already discussed that these metals are those which are to be kept in kerosene, as they are highly reactive. They react with air, they react with water, and the reactions are highly exothermic. So that's why it is being told to keep them in kerosene. Similarly, when we talk about gold, silver, mercury, like gold, silver, when we talk about, they are being used for making ornaments, and we know that if we are having a gold ornament, so many years will pass on, but the shining and the appearance will not go away. So that means it is not reactive with air and water. Now, seeing the reactivity series, potassium, sodium, calcium, these are highly reactive. Then the reactivity series is decreasing. The reactivity of metals is decreasing as we are going from top to bottom. Considering this, we are going to study some reactions. Reaction of metals with metal salt solution. If I am having iron nail and I am putting that iron nail in copper sulfate solution. Copper sulfate solution is blue in color. So when you will add the iron nails in copper sulfate, you will see that the blue color of copper sulfate will fade away after some time. The solution will become green in color because of the formation of iron sulfate, and copper get released. So this copper in brown layer forms a layer on the iron nail. Like this. Iron nail when kept in copper sulfate. So the copper sulfate is blue in color. So the copper from copper sulfate is displaced by iron, and the copper, since it is displaced, it has come and formed a layer on this iron nail as brown in color. The solution copper sulfate is blue in color, but the solution, so from the solution copper has come to the iron, so the color of the solution will fade away. Now here we can understand one thing. This is a displacement reaction which was there in first chapter. Now the basic idea behind is this: iron has displaced copper from copper sulfate. Iron, since it is more reactive, then only it is able to displace copper. Why? Because if we see this reactivity series, iron is here and copper is here. So above element is high reactive. Since iron is above to copper, so iron has displaced copper, and therefore the reaction is feasible or possible. Similarly, aluminium is reacting with copper sulfate. Again, when we see the reactivity series, aluminium is here, copper is here. Since aluminium is at the top, so we can say that aluminium can displace copper from its solution. So aluminium is going to displace copper, so aluminium sulfate will get formed and copper will get free. Similarly, zinc when reacts with copper sulfate, so here again zinc and copper, zinc is above in the reactivity series, zinc can displace copper and it forms zinc sulfate and copper is moved out. But if in case we do the opposite way means if suppose I am taking copper and zinc sulfate. So if I take copper plus zinc sulfate, since copper is down in the reactivity series, it is less reactive, then it is not going to displace zinc from zinc sulfate and the reaction will not be possible. So by the reactivity series, it is clear that above elements can displace downward elements. Like if suppose I have taken copper and silver nitrate, so copper is above to silver in the reactivity series. Here we can see copper is above and silver is down. So copper can displace silver from its solution. So copper has displaced silver, copper nitrate is formed and silver is free. Similarly, when silver is reacting with copper sulfate, since silver is less reactive than copper, so there will be no reaction. So these reactions are displacement reaction, wherein single element displaces another element from its compound. Now, to remember this, you should know one thing. If suppose a teacher is there in the class and says you to stand up from here as she want to sit there, then with respect you are going to move from there and allow the teacher to sit. So here teacher has displaced your position and you are at the teacher's place now, you are standing. So here we can say that teacher has displaced student as teacher is more reactive, teacher has more commanding power. If in case suppose your enemy is standing nearby and he is saying that please move from here, I want to sit, will you move? No. So there your enemy is less reactive than you. You are not going to give place. Now the next topic is chemical properties of nonmetals. After completing metals, we are coming to nonmetals. So talking about nonmetals, first thing, nonmetals are electronegative. Electronegative means they are going to gain electron and gets negative charge. Like Cl minus is a negatively charged ion since it has electronic configuration 287. In the last shell it has 7 electrons. To get stable it requires only 1 electron. So therefore it's very easy for chlorine to get that 1 electron and forms Cl minus. So all the nonmetals are electronegative. They gain electron and gets negative charge. The first chemical reaction, chemical property is reaction with oxygen. Nonmetals when combined with oxygen, they form non-metallic oxides. Like carbon is a nonmetal, combining with O2 to forms CO2, carbon dioxide. Similarly, sulfur combining with oxygen to forms sulfur dioxide SO2. Now, non-metallic oxides like CO2, SO2 are acidic in nature. How to check? By using litmus. If we are going to take blue litmus and dip a non-metallic oxide to the litmus, the blue litmus will convert to red. When carbon dioxide, that is a non-metallic oxide, is combining with water, it forms carbonic acid. Similarly, sulfur dioxide, which is a non-metallic oxide, combines with water to form H2SO3 sulfurous acid. If the SO2 gas further oxidation is being done, means more of supply of oxygen is given, it forms sulfur trioxide, and in this sulfur trioxide, if water is added, it forms sulfuric acid H2SO4. So here I wrote this reaction to explain you the difference between sulfurous acid and sulfuric acid. Sulfurous acid is formed directly by adding water to sulfur dioxide, but to get sulfuric acid we need sulfur trioxide, which we get by further oxidation of SO2. Next chemical reaction is reaction of nonmetal with chlorine. Hydrogen H2, it's a nonmetal, combining with Cl2 to form hydrogen chloride. So we can say that nonmetals combine with chlorine to form chloride. Next is phosphorus combining with chlorine to form phosphochloride PCl3. Now the next reaction is reaction of nonmetals with hydrogen. The first reaction, hydrogen combines with sulfur. Sulfur is a nonmetal. So it forms hydrogen sulfide H2S gas. Similarly, when nitrogen, which is a nonmetal, combines with hydrogen, it forms NH3, that is ammonia. So we understood three chemical properties: reaction with oxygen, reaction with chlorine, reaction with hydrogen. But we have not studied the reaction with water and acid, because nonmetals are not reactive to water as well as they are not reactive to acid. Now the next reaction left is reaction of metal with non-metal that need a further extension which leads to ionic bonding. So that we will start in the next video. Till then, goodbye.
Thanks for watching. If you like this video, make sure to like, share and subscribe for more.